Hopefully this will still record. All right. Looks like it's recording. All right, let's get started. Sorry that took so long. And I think, let's see, nobody's waiting to get in at the moment, so we should be good to go. All right, so you should have seen, no, you haven't seen these problems. These are the 2019 FRQs numbers 4 and 6 that they suggested that we try to go through. So we're going to take a look at those right now. So if you're just trying to get them up on your own computer or on your phone or whatever, it's 2019 FRQs 4 and 6. And then we're going to do some of the parts of the other suggested questions that they put out a couple days ago that I sent out to you guys. So the first couple here should, I think, be pretty straightforward. We're starting with a cylindrical barrel. Gives us the diameter, and it tells us that it's got some water in it. And we want to find the rate of change of the volume of the water in the barrel with respect to time when the height is 4. And so it gives us the rate of change of the height of the water. And if we're looking for the rate of change of the volume, then we just need to use the volume formula that they gave to us. So they gave, there we go. They gave us volume equals pi r squared h. Now, since we're talking about how one quantity is changing with respect to time, that means this is a related rate question, which means we're going to have to differentiate with respect to time. And the main thing to remember when you're doing your related rates is that anytime you are doing one, you can't plug anything in until after you've taken the derivative, unless that quantity is not changing at all in the problem. So if you look at our problem, we know that the diameter of this cylinder is 2 feet, which means the radius is 1 foot. That is not changing. This isn't a cone or a pyramid or something. The radius is the same from the base all the way to the other base. So we can plug in that the volume is now just equal to pi h. Since our radius is 1, r squared will be 1. We can plug that in. And now we'll take the derivative of this with respect to t to get dv dt equals pi dh dt. Since we're taking the derivative of a term with h with respect to t, we get the dh dt term attached to the end of it. And we know what dh given to us in the problem, so this is now negative pi over 10 root h is equal to dv dt. And we want to know what this is when the height is 4 feet. So this will be negative 2 pi over 10, or negative pi over 5, and our units are feet. So it should be feet per, t is measured in seconds, so feet per second. Any questions on that, on part A? Nothing in the chat there, so. Oh yeah, sorry, yeah. This is volume, negative pi over 5 feet cubed per second, yeah. Thank you, whoever that was, Justin. And Ada. All right, good? Any other issues with A? All right, for part B, when the height of the water is 3 feet, we want to know, is the rate of change of the height of the water increasing or decreasing with respect to time? So that's asking us, is the rate of change of the height, that's dh dt, is this increasing or decreasing? Which means that we need to figure out what the sign of the derivative of the dh dt function is. So we'll take the derivative of it, again, with respect to t. So the second derivative of h with respect to t should be the derivative of negative 1/10 root h with respect to t. So the derivative of negative 1/10 root h is negative 1/10 times the derivative of root h, which is 1 over 2 root h. And since we're taking the derivative of an h term with respect to t, there's another dh dt term that gets attached to the end of it. Everybody good with that being the derivative there? Okay. So then when we simplify this out, we'll have to replace the dh dt with our original dh dt. So this becomes negative 1 over 20 root h times dh dt, which is negative 1 over 10 times root h. The root h's will cancel, and we just end up with 1 over 200. Since that's a positive number, that means that the derivative of dh dt is positive, which means that dh dt is increasing. And your reasoning would be it's increasing because its derivative at t equals 3 is positive. In fact, its derivative at any value, or sorry, at h equals 3, its derivative at any h value is positive because those h's cancel out and you get 1/200th either way. Any questions on that? Everybody good there? That's right, Nick. Yeah, the h equals 3 doesn't seem to matter. Am I going to add volume and surface area functions to the AB sheet, Jack? No. They should be giving you, they give you all of those. The only thing that they wouldn't give you would be like a rectangular box or something like that. So otherwise you should be good. Okay, everybody good? Adrian, no, I highly doubt you'll see anything about Newton's law of cooling on the test. All right, next part here. At t equals 0, the height of the water is 5. So that's 0, 5 is a point that we know is on this. We want to use separation of variables to find an expression for h. So if he was negative 1/10 root h, then to separate the variables, this becomes dh over root h equals negative 1/10. And we will, sorry, negative 1/10 dt. And then we'll integrate both sides. The integral of dh over root h, that's h to the negative 1/2, so it goes up to h to the 1/2. You divide by the 1/2, that becomes 2 root h equals negative 1/10 t plus a constant. And then we'll use our initial condition that t is 0, h is 5, to get a constant of 2 root 5. Then from there, we can plug that all back in to our solution right here. 2 root h equals negative 1/10 t plus 2 root 5. Divide by 2. And square it. And that should be good enough. Yeah, Newton's method, I highly doubt you'll have to use. There we go. Let me go back to the chat here. Okay, let's see here. Newton's method, Jack, I highly doubt you'll have to use that. I already answered that. Yeah, there's going to be some implicit differentiation for sure. So I'd be surprised if there wasn't. Any questions there on part C? Yes, Emil, there will certainly be differential equations. For example, this is a problem they said that you should for sure practice, and this is a differential equation. All right, let's take a look at this next one here. Yeah, you saw squeeze theorem, sandwich theorem. That was in their list of questions to review. So I would suggest taking a look at that. We're going to do a little bit with that in a minute here. There's a sandwich theorem or a squeeze theorem piece at the end of this particular problem that we're about to start. This one's really similar to one of the ones we were doing this morning that they posted up, and we're suggesting that you guys take a look at. Now, sandwich theorem's always been on the AP test, Adrian. It's always been covered material. It hasn't shown up in about the last 15 or 20 years until this past year it showed up. I haven't seen a question on it in a long, long time until they put one on last year. All right. We've got f, g, and h, which are all twice differentiable functions. We got g of 2 equals h of 2, which is equal to 4. And we're given a line that we know is tangent to both of them, to both g and h at x equals 2. We want to find h prime of 2. So if this line is tangent to h at x equals 2, then the slope of this line, which since this is in between point slope and slope intercept form, the slope is 2/3 there. That means that h prime of 2 should be equal to 2/3. Part A should be pretty straightforward there. Any questions on part A?
What work do they expect for that?
No work.
Okay.
Yep, just that's good enough. I mean, maybe you just write the slope there as 2/3 and then write your answer. But on their scoring guide, it just says answer is worth 1 point. So, all right, for part B, we want to find a prime of x and then find a prime of 2. So a prime of x should be the derivative of 3x cubed h of x, which is a product rule problem. So 3x cubed h prime of x plus 9x squared h of x. So there's your expression for a prime, just using the product rule. And then a prime of 2 should be 3 times 2 cubed, which is 24. H prime of 2, which is 2/3. And then we've got 2 squared is 4 times 9 is 36. And then h of 2, which they gave you to be 4. And if you want to simplify that out and get an answer, you can, but you don't need to because it's a numeric answer and you don't have to simplify them. So if we want to, we can. That's what, 16 plus 144. Is that right? So 160. I don't know why it's doing that. Any issues with part B there? Everybody okay on part B? All right. Let's take a look at part C. We've got, we know that the function h satisfies x squared minus 4 over 1 minus f of x cubed for x not equal to 2. And we know that we can evaluate the limit as x approaches 2 of h using L'Hopital's rule. We want to find f of 2 and f prime of 2. So once again, this is really similar to what we were working on this morning if you were in any of those sets, just kind of different numbers. We know that it can be evaluated using L'Hopital's rule, which means that it's either 0 over 0 or infinity over infinity for the numerator and the denominator there. And so if we look for what's the limit as x approaches 2 of h of x, well, we can just plug in 2, which should give us 4 minus 4 over 1 minus f of 2 cubed. And we know that that's supposed to equal now 0 over 0. So that means that the denominator of this, 1 minus f of 2 cubed, has to equal 0, which tells us that f of 2 cubed equals 1, or f of 2 then has to be 1. Any questions on the first part of part C? Okay, cool. So now about f prime of 2, well, since we have 0 over 0, since we have this indeterminate form, we know that the limit as x approaches 2 of h of x should be equal to the limit as x approaches 2 of the derivative of the top, which is 2x, and the derivative of the bottom, and that's negative, and then f of x cubed's derivative is 3 f of x squared times f prime of x, because that's a function within a function. It's a function cubed, so that's 3 times the function squared times the derivative of the function using the chain rule. Everybody good with that so far? Any issues with that? Okay. And so now we need to think about some of the information that's been given to us here. And if we think back to the beginning of the problem, it told us that g of 2 and h of 2 were both equal to 4. So we know that h of 2 is 4, and we know that h is a differentiable function, which means that h is a continuous function. So since h is a continuous function, then the limit as x approaches 2 of h of x, I'm going to write this here, since h is continuous, that means that the limit as x approaches 2 of h of x has to equal h of 2, which is 4, which means that this limit here has to equal 4. So we know that 2 times 2 over negative 3, and then f of 2 was 1, so negative 3 times 1 squared times f prime of x has to equal 4. And we can pretty easily solve that. Looks like that'll give us f prime of x has to equal, should be negative 1/3, looks like. Any issues with that? Let's see. Let me see what you guys were asking up here. Yeah. So man, lots of questions up here. Okay. Yeah, L'Hopital's rule only works for indeterminate functions, 0 over 0 or infinity over infinity, Jack. Yeah, looks like Adrian said that. Twice differentiable, Tina, just like Adrian said, is it means that you can differentiate it twice. But any function that is differentiable is continuous. So if a function is twice differentiable, it means that the function is continuous and its derivative is also continuous. So let's see here. Do you need to provide an explanation for why it's continuous? Just a quick statement is fine if it says that it's differentiable. You can just say that it's continuous, and that's good enough. Yeah, I mean, just say h is differentiable, so continuous, and then good enough. Does that answer everybody's questions? I think. Anybody still have questions on any of that? Okay, I'm waiting, Adrian. Okay, I'm still waiting, Adrian. Third section of the first problem. When I solve the equation, do you have to have h equal to something? As in when I get, do I have to write h equals this, or can I just write what's in the parentheses squared? You need to have the h equals in front of it, or h of t equals, something like that. Yeah, it has to be solved for h equals, and you can't just write this part of it. You have to actually write h equals this. But yeah, it has to be solved completely for h. All right, cool. All right, back to where we were here. So for part D, it tells us that we know that on the interval from 1 to 3, g of x is always less than or equal to h of x. And then they're making up a new function, k of x, and saying that k is a function that is between g of x and h of x. For the open interval 1 to 3, we want to know, is k continuous at x equals 2? And so we know that the limit as x approaches 2 of f of x is equal to 4. And we also know that the limit as x approaches 2 of h of x is equal to 4. And so that tells us that by the squeeze theorem, or by the sandwich theorem, we'll write it out, by the squeeze theorem, the limit as the limit as x approaches 2 of k of x is also equal to 4. Now, just having this information about the limit equaling 4 isn't enough to say that it's continuous. But we also know that g of 2, which equals, we'll say that 4 equals g of 2, has to be less than or equal to k of x, which has to be less than or k of 2, which has to be less than or equal to h of 2, which is also 4. And so therefore, if g of 2 is 4 and h of 2 is 4 and k of 2 has to be less than or equal to both of those, or greater than or equal to 4 and less than or equal to 4, that means that k of 2 has to exist and it has to equal 4. And so we've shown that k of 2 is 4 and the limit as x approaches 2 of k is 4. And so therefore, yes, it is continuous because it meets all three criteria for a function to be continuous. The limit as x approaches 2 exists, k of 2 exists, and those two values are the same. Any questions on that? Was it? Did I say f? Oh, sorry. Limit as x approaches 2 of g of x. Yeah. Sorry, not f of x, g of x. There's too many letters in this one. I know that k of 2 has to exist, Adrian, because I know that on this entire interval from 1 to 3, this statement here is true, that g of x is less than or equal to k of x is less than or equal to h of x. And so if there's a value on the interval from 1 to 3 where k doesn't exist, that inequality is no longer true. Did I miss anybody else's questions up here? It doesn't look like it. All right. Yes, Dylan, you'll need to specify. You always got to specify satisfy what theorem? Squeeze theorem or sandwich theorem? You could write either one. Either one's acceptable. All right. Any other issues with that one before we move on? All right. So this is another one of the problems that they put up that they suggested. I sent these out to you guys, and the answers were up for these. So this is one that we didn't do this morning at all. So I figured we should take a look at it real quick. But it's all up on the stuff that I sent out through Remind a while ago. So first off, we know that f is some function that's sine pi x plus ln 2 minus x. G is twice differentiable and follows this chart. And H has 5 line segments and follows this graph. And we are going to try to answer questions about it. I think it's just those 5. So if we want to find the slope of the line tangent to f at x equals 1, then the first thing that we have to do is find the derivative of f. So we'll do that right here. F prime of x should be equal to the derivative of sine of pi x, which is pi cosine pi x. And then the derivative of ln 2 minus x, that's ln of u, which is 1 over u times the derivative of u, and the derivative, sorry, it's 2 minus x. 1 over u times the derivative of 2 minus x, which is negative 1. So we'll throw in a negative 1 there. And it asks us to evaluate that at 1, I believe. So that will be pi times the cosine of pi minus 1 over 2 minus 1, which comes out to be the cosine of pi is negative 1. This is negative pi minus 1. Any issues there with part A? Everybody good there? No, you don't need to put m equals, Chun. Just make sure you make it clear what your answer is and you're good. Yeah, on the actual test, Adrian, you still don't need to. So how do you show the work? I mean, you find f prime and plug in 1 and get an answer. I mean, you just do what I did. Find the derivative and then evaluate it at x equals 1. No, you don't need to write out the initial question or anything. No, just do the problem. All right, k, we got a new function k of x. K of x is h of f of x plus 2. So they're going to test whether or not you can take the derivative using the chain rule here. So this is h of a function u inside of it. So it should be h prime of f of x plus 2 times the derivative of f of x plus 2, which is f prime of x. So that should be k prime using the chain rule. And then we want to find k prime of 1. So k prime of 1 should be h prime of f of 1 plus 2 times f prime of 1. So first we're going to need to figure out what f of 1 is. And I think that was in our, okay, f of 1 is just from this. So if we want to figure out what f of 1 is, that's the sine of pi, which is 0, plus the ln of 1, which is also 0. So f of 1 is just 0. So f of 1 is 0. So now we're looking at h prime of 2 times f prime of 1, which we already found. F prime of 1 was negative pi minus 1. And then h prime of 2, we should be able to find from our graph. At 2, we're looking for the derivative, which is the slope. This is negative. It's going down 1 and over 3. So h prime of 2 should be negative 1/3. So going back over here, we've now got negative 1/3 times negative pi minus 1. Any questions on that one? And that's a numeric answer, so no reason to simplify unless you want. You can write pi over 3 plus 1/3. That's fine, but no particular reason to. Juliana, to find h prime, I went to my graph of h and I said, well, h prime of 2 is just the slope of this function at 2. Well, it's a linear piece, and so the slope of it is negative 1 over 3, negative 1/3. Does that make sense, Juliana? Cool. All right. Other questions on that part? We're feeling okay about it. Okay. Next part. Evaluate the integral from -5 to -1 of g prime. That's just a simple fundamental theorem of calculus second part question. This should just be the integral of g prime is g of x. So we'll evaluate that from -5 to -1. That's just g of -1 minus g of -5. And those numbers should both just come straight from the chart. G of -1 is -2, and g of -5 is -3. Sorry, g of -1 is 1, and g of -5 is 10. One minus 10 gives you -9. G of 1, yeah. Any questions on part C there? Jack, if part C was the derivative of the integral, would you use the g prime table? So if it said take the derivative, evaluate the derivative of the integral from -5 to -1 of this, no. The derivative of the integral from -5 to -1 of g prime, you'd find the integral from -5 to -1 of g prime, which is -9, and then you take the derivative of that and you just get 0. The first part of the fundamental theorem of calculus only works if it's going from a constant to x up here. It's not going from a constant to x, it's going from a constant to another constant. So if I find that integral, I'm going to get a number from it, and then when I take its derivative, it'll just be 0. They won't ask you. I would highly doubt it if they asked you that. But other questions on that part? All right, part D here. So for part D, we are trying to rewrite this limit. The limit as n approaches infinity of the sum from k equals 1 to n of h of -1 plus 5k over n times 5 over n as a definite integral. And it's telling us that the lower bound is -1. We should have been able to figure that out anyway. When I updated your test sheet today, I put on the two things that the delta x value over here, this is 5 over n, is delta x, is always equal to b minus a over n. So this is, so b minus a equals 5, which tells us that the length of the interval is 5. and that we know we're starting at -1. We could have figured that out because this is always a plus k delta x, and so the a value is -1. But this integral is the integral from -1, and then 5 units from -1 is 4. So the integral from -1 to 4, and our function is h of x. Everybody good with setting that up as the integral from -1 to 4 of h? Any questions on that part? Okay. So then we'll evaluate that integral from -1 to 4 of h, which means we're going to have to go back here and take a look at our graph. We're going from -1 to 4. So first thing is we've got a triangular piece that's above. The area of that should be 1/2 base times height, or just a half. It's above the x-axis, so that should be positive. Then we've got this triangular piece that's below the x-axis, and the height of that triangle is 1, and then the base of that triangle is 3.5. We know that that's only going a half over here because this is a linear piece and the slope is 2. So it's 7/2 times 1 divided by 2, which should be -7/4. So we've got 1/2 minus 7/4. And then we've got this little chunk right here, which is back above. It's got a height of 1 and a base of a half. Half of that is plus 1/4. So we've got, or 2/4 minus 7/4, which is -5/4, plus the 1/4, which should be -4/4 or -1. Any issues with that? You guys can still hear me, right?
Yes.
All right, just making sure. Okay. Moving on then to the last part of this. We want to know what is the fewest number of horizontal tangents that g of x could have on the interval from -5 to 0. So horizontal tangent means that g prime is equal to 0. So we want to know what's the fewest number of times that g prime equals 0. Well, if we go back over here, it clearly crossed from -1 to 4. So there's one place where g prime had to be 0. And from 1 to -2, it crossed back through again. So there's a second time. So the fewest number of horizontal tangents that it could possibly have is 2. On that interval from -5 to 0. Does that make sense? Any questions on that? No, you don't have to specifically state, I don't think, IVT on that one. You could, but you could just say, Shri and Oishi, I would just say the graph or G prime only changes signs at a minimum of, or it has to change signs a minimum of 2 times, once between -4 and -3, and once between -2 and -1. If you threw in IVT to that also, then great. But I don't think that if you didn't state IVT, you wouldn't lose the points, I don't think. And Shri, there's no work to show per se other than writing a short statement that says why you chose 2 as your number of times. So, any other questions on that one? All right. Yeah, if you just say where it crosses through 0, that's fine, Sean. Okay. Now, these two problems, they're A and G here, and there are a couple of things. We did a bunch of the parts that were in between these, but we never actually did these ones because they kind of jammed together stuff from other problems. And this is a different limit than they gave in the original problem. And then this part A was never part of something I'd seen before until a day or two ago. So I figured since they posted these, we'd do these two also. But these are the last two that we're going to do right now. And they're the last ones from all the stuff that they recommended. We'll have gone over everything that they recommended you guys do specifically for this year's exam. So hopefully that'll be good. So we've dealt with this chart before. We did some stuff with this chart before, and we dealt with this graph before. We did some stuff with it, but they didn't ever combine them together. So it asks us to find the derivative with respect to t of f of t times v sub p of t at t equals 1. So they're just testing, do you know the product rule? So the derivative is f of t times v sub p prime of t plus v sub p of t times f prime of t. And we're going to evaluate that at t equals 1. So f of 1 is given to us as 1 from the graph. V sub p prime at 1. We had, I believe, summation for this in some other way, or it may have, no, it gives it to us. Okay. At t equals 1, it is known that the acceleration, which is v sub p prime at 1, should be negative 10. So that's negative 10. And then we know that v sub p of 1 is negative 29. And f prime at 1 is just the slope of this line, which is a rise of 2 and a run of 1, so 2. And this is just a numeric answer, so if you want to leave it, you can. If you want to say that that equals, what is that, negative 10 minus 58, so negative 6, I don't know why I wrote a 1 there, negative 68. That's good too. Any questions on that, on part A there? Pretty straightforward, I hope. All right, and then B, C, D, E, and F are ones we've done other days that I posted. I posted the video with those up already. And so part G asks us to find the limit as t approaches 1 of this. And this should actually be pretty straightforward here because this ends up being e to the first power, or just e, minus 3 times f of 1, which is just 3, over v sub p of 1, which was negative 29, minus the cosine of pi, which is just plus 1. Since the cosine of pi is negative 1, subtract it, it makes it a plus 1. We end up with e minus 3 over 28. And that's that. Any issues with that part? Oh, thank you. Negative 28. I can add positives and negatives. Exactly. Yeah. Don't simplify it, right, Achuth? Just leave it as a numeric, unsimplified numeric answer. All right, that's it. You'll get a 5, hopefully. Any other questions in general? Okay, so Jack, in order to actually get to the AP test, do I just log into my AP? Yeah, I should just said it, but there should be a link on there. So log into your MyAP and you should get it. Yeah, you should have got an email about it. You weren't on the, yeah, you can just click on your ticket and that should get you there. You'll probably have to log in once you click on it, Molly, but yes. Everybody's emails should be getting those emails. There was only one person on the list that had a messed up email, and I've been sending that person multiple messages and not hearing back. So who knows? But yeah, you still have to, you click on the ticket and then you got to go in and type in all your information. And there's the thing that says you don't cheat and all that stuff. You're not going to cheat and blah, blah, blah. Yeah, you're not going to be able to get in on 2 devices, I wouldn't imagine. Not at once. Let's see. It says that you have 25 minutes to work and 5 minutes to submit, Justin, and I can't imagine that they're going to let you, you've got those 5 minutes to submit. I guess if you can submit it in less than that, you're probably okay. But I don't know. Yeah, Chun apparently took a test today, so he might be able to tell you about that. But yeah, and as far as Juliana, as far as derivative calculators, Desmos, all that, they can't. Once you open up their browser or whatever and get into it, obviously, I think they're going to sort of lock it down on there. But if you're doing it, you got your phone, you got your 12 other laptops in your house or whatever. They can't stop you from doing it, but just be aware that typing it in and doing all that might take you more time than it's worth if it's just an easy one. So. Anybody else have any other questions at the moment? Sure, Jack. You can play your video games at the same time. Ben, as far as I know, if it was true in the demo, it should be true during the test. Now, that's just what they've told us, but can't promise that that's true. But like I said, Chun's already taken one. He just said yes, so I guess so. Okay, so Molly, you want me to talk about the derivatives of inverse functions? So that's probably helpful to everybody. I'll do one real quick. So I'm going to write out the inverse function rule. If f and g are inverses, that means that f contains a point a, b, and g then contains the point b, a. That f prime of a is 1 over g prime of b, or vice versa. G prime of b is equal to 1 over f prime of a. Either way you want to write it is fine. So that's the basic inverse rule. And Molly, you want me to just use one of those problems you sent me earlier? Okay, let me pull that up. All right. Okay, so we've got if g is the inverse of f and f of x equals 1 over x, we want to find g prime of 3. Okay, so if we're looking for g prime of 3, that means we know that g contains a point 3 something and f contains a point something 3. And so our goal is to not have to actually find g of x. Now, it's easy enough to find g of x because we can find the inverse of 1 over x. But for many functions, that's not as easy to do. And so what we need to do is we need to figure out what value of x gives us 3 for f of x. So we're going to say 3 equals 1 over x. And we'll say, well, that's true when x equals 1/3. So this value is now 1/3. We can plug that straight into our formula, which will tell us that g prime of 3 should be equal to 1 over f prime of 1/3. The derivative of 1 over x is negative 1 over x squared. So I'll go to another page here. It's 1 over f prime of 1/3 with f of x equal to 1 over x. And so f prime of x is negative 1 over x squared, which means that this should be 1 over negative 1 over 1/3 squared. If that was the AP test, just leave it like that. But this is 1/3 squared, which is 1/9. 1 over 1/9 is just 9, so this is negative 1/9. Does that make sense, Molly? Or anybody else that was paying attention and not going on and on in the chat? Did anybody actually ask a question that was worthwhile in the chat, or no? You all just making fun of each other? Okay, back to it. There you go, Julianne. Does that help? Cool. Sean asked something. What did Sean ask? I just missed it. Sean, how will I take attendance after the AP test? Oh, well, just by making sure that you're doing all of the mini assignments that I'm going to assign to you. I don't know. It'll be easy. It'll probably be something like, send me a remind message that says you're alive, and I will mark that you're present. For whoever wanted me to go to the page before, was that long enough there? Yeah? You're good? Oh, good. Somebody's going to join now.